All right, this video tutorial is on the 10.4 Big Ideas Geometry section, inscribed angles and polygons. So the main two objectives are to use both inscribed angles and polygons within the circles. So main thing to talk about an inscribed angle is it's different from a central angle because an inscribed angle has to have its vertex on the circle. When we talked about central angles in the last section, the vertex was at the center. So those sides of the inscribed angle, like this red inscribed angle down here, this AB and BC are chords. Chords make up that part of the inscribed angle. Now the arc that is between them on the outside of that circle, this blue is called an intercepted arc. If those endpoints of the chord or the arc lie on the side of an inscribed angle, then it says that it subtends the angle, and it's inside that angle. So first theorem we're going to talk about is the formula to find the measure of an inscribed angle relative to its arc. So the measure of the inscribed angle is equal to 1/2 of its intercepted arc. So if you're given the measure of this arc AB right here, the inscribed angle on the inside is going to be half that. If you think vice versa and you flip that around, you're given the inscribed angle, but you want to find the measure of the arc, you would double that because that's the opposite of half. So let's find the indicated measures of these two parts of the circle. So we're given a couple different inscribed angles with some intercepted arcs. First, let's find the measure of the inscribed angle T. So its intercepted arc from inscribed angle T is this 48 degrees or arc RS right here on the outside. The formula says that you take 1/2 the arc of the outside to get the inside because you're going from out to in, big to small. So you take half of 48. The inscribed angle is measured to be 24 degrees. Now part B, to find the measure of arc QR, which is the green arc indicated there. First, we need to find the measure of this arc right here using this inscribed angle of this 50 degrees. And since we are going from in to out, we are getting from smaller to bigger. So that means we are going to multiply by 2 to get the arc of QT on the outside. So 2 times 50 is to be 100 degrees. So we're given that that purple one is 100. We're given that this arc right here is 48. We need to find the green arc up above. Because that TQR, or this TR, is a diameter, notice that it's going through the center, this is a semicircle. So both of the purple and the green have to add to equal 180 degrees. You subtract 100 from 180, and you get a measure of 80 degrees for your arc QR. Moving on to find measure of arc RS and your inscribed angle STR. Let's find that arc measure. So SR is right there, the indicated red arc. It matches up with this inscribed angle of 31 degrees right here. So since we are going from in to out, we are getting from small to big. So we would multiply it by 2. 2 times 31 is 62 degrees for that arc measure. Now to use that same arc to find the inscribed angle right there, and this green one, you're also using the same arc. The side points match up, and you would go from out to in, which is big to small. You multiply by 1/2 to get 31 degrees. So those two inscribed angles are equal because they match the same intercepted arc. So if 2 inscribed angles of a circle intercept an arc, then those angles are congruent, just like that last example that we talked about. So given that angle E is 75 degrees, we need to find the measure of angle F. So 75 is going to be used to find the measure of arc GH. Going from in to out, we're going to multiply by 2 to get the arc, and then divide by 2 or multiply by 1/2, but since we know of the inscribed angles of a circle theorem, both of those inscribed angles have to be the same, which is 75 degrees. Looking at inscribed polygons. So when all of the vertices lie inside a circle, it's called an inscribed polygon, like this blue pentagon right here. It's inside that circumscribed circle. So looking at these next two theorems, if you have a right triangle as the specific shape that's inscribed in a circle, then the hypotenuse is a diameter of that circle, because the inscribed angle of this angle B right here, if it's to be a right triangle, this has to be a right angle. And the formula for going from inscribed angle to outer intercepted arc is times 2. So 90 times 2 has to be 180, which would then make this a semicircle. If you've got a quadrilateral, that can only be inscribed in a circle if its opposite angles are supplementary. So kind of looking at the same idea, D has an inscribed angle where all of the arcs on the outside and all of the F arcs opposite it have to be supplementary. So D plus F and E plus G both have to equal 180. So we're going to find the value of each one of these variables using these inscribed polygons. So this is 2x. We know that AB is a diameter because it passes through the center. So this 2x represents a right triangle or a right angle. So 2x is equal to 90, divide by 2, x is 45. Now using it for polygons, for part B, we know that all of the opposite inscribed angles have to be supplementary. So z plus 80 has to equal 180, and y plus 120 has to equal 180. So you would then just subtract 80 on both sides to get z equals 100. And then for y and 120, you would subtract 120 on both sides to get y equals 60.